So let's say we were asked to factorise x squared plus 6x plus 9. Well, we want to look for two numbers that multiply to give us 9 and add together to give us 6. So that's going to be 3 and 3. So when we factorise this, in one bracket we get x plus 3, and in the other bracket we also get x plus 3. So I can write that as x plus 3 squared. Let's have a look at another one. For example, x squared plus 10x plus 25. Well, two numbers that multiply to 25 and add to 10, that's going to be 5 and 5. So x plus 5, x plus 5. So I could write that as x plus 5 squared. And if we look at one more, x squared subtract 2x plus 1. Well, two numbers that multiply to be positive 1, but they add to be negative 2. That's going to be negative 1 and negative 1. So we get x minus 1 times x minus 1 when we factorise, which is just x minus 1 squared. Now, what I want to have a look at, and what's going to be important for the rest of this video, is the relationship between this number here, the 6, and the 9. Or over here, it would be the 10 and the 25, or the minus 2 and the 1. So let's have a look at what I've actually done to go from 6 to 9 here, or from 10 to 25, or from minus 2 to 1. And then we're going to have a look at the numbers that actually appear in our square brackets. So if I take my number 6 and I divide it by 2 and then I square it, I end up, well, 6 divided by 2 is just 3, and 3 squared is 9. So notice how if I take this 6, if I divide it by 2, I get 3, and that's the number that's popping up in here. And then if I square that number, I get 9. Now the same happens for the rest. If I take my number 10, if I take 10 and I divide it by 2 and I square it, 10 divided by 2 is just 5, 5 being the number that we see here. And if I square that, I get 25, which is the number that I get on the end. And the same occurs for this final one. If I take my negative 2, and again I divide it by 2, so I halve it, and then square it, well, this is just the same as negative 1 squared, which is the number that I'm seeing go into this bracket here. And minus 1 squared is just positive 1, which is the number that I'm seeing on the end here. So we've kind of got this relationship that the b value, if this is, we have an imaginary value at the one here, this is our a, and this is just a 1 in this case. This number 6 is our b, and this number 9 is our c. Our b value gets divided by 2, and that is what we see popping up in our square bracket when we factorise. And then if I divide it by 2 and then I square it, I get my c value. And that's going to be really important for the rest of this video. So let's come down here and take an example of us fully completing the square. So let's say we were asked to solve when x squared plus 6x minus 4 was equal to 0. Okay, if I was to try and factorise this, I would have big problems because I can't think of two numbers that multiply to minus 4 and add to positive 6. So I end up in a bit of trouble. So what I do is similar to what we saw in the pattern just before. I take my number 6, I divide it by 2, and then I square it. Now 6 divided by 2 is 3, and 3 squared is 9. So we're going to hang on to those numbers. So what I'm going to do is I'm going to take my x squared plus 6x. Now instead of a minus 4, it would be much nicer if I had a plus 9 here, this number that I generated on the end, because I can then factorise that. Now I can't just get rid of my minus 4, I can't just kick it out, so I still have my minus 4 then. And also, I can't just add 9 because I messed this equation up. So on the end here, I'm going to subtract 9. So I haven't changed anything about this equation, but I've manipulated it into two sections. I've got this section here and this section here now. Now this first section, I can factorise. Two numbers that multiply to give me 9 and add to give me 6, well, it's 3 twice. So x plus 3 squared. Notice that this number here is the number that is coming into our brackets, which are being squared when we factorise. And now I have left over here minus 13 in total, and that has to be equal to 0. Now this is something that I can start to solve. If I move my 13 over to the other side, x plus 3 squared needs to be 13. So the square root of both sides, I get x plus 3, has to be plus or minus the square root of 13. And well, if I subtract 3 from both sides, x can be minus 3 plus or minus the square root of 13. So I have two solutions there. I could have minus 3 plus the square root of 13, or I could have minus 3 subtract the square root of 13. And if you pop those into a calculator, one of your solutions would be 0.61, and the other solution would be negative 6.61. So we've actually solved this equation by doing what we call completing the square. And it relies heavily on this part up the top here, which we saw that pattern just before. Let's take a look at another example. So we'll come down here. So let's say we have x squared minus 7x plus 1, and we need to try and work out when that is equal to 0. Well, you could, and I would encourage you to, try and find two numbers that multiply to positive 1 and add to minus 7, because if that was the case, we would have a nice factorization. But unfortunately, in this particular case, there aren't any, and we're going to have to complete the square. So the first thing that we do is we take our minus 7, we divide it by 2, and we square it, okay? And that's going to allow us to pop a number in here that will allow for a nice factorization, a square factorization, which is why it's called completing the square. Now, if we evaluated this, we would get 49 over 4. So let's rewrite this expression as x squared, take 7x. I'm then going to add on my negative 7 over 2 squared. I've still got my plus 1, but I have to also then get rid of the bit that I added in. I can't just go adding things into my equation as I feel free. And that needs to be equal to 0. Okay, well, what we learned from the pattern is that this part here will factorize nicely into a square bracket. So I end up with my x and whatever this bit in here is. So x subtract 7 over 2, all squared. So that's factorized my bit in these square brackets here. And I end up with plus 1 minus 49 over 4. And that all has to be equal to 0. Now I can rearrange this and I can start to solve for this equation. So I need to look for when x take 7 over 2 squared. Now I can rewrite this 1 as a 4 over 4. Like that. So when I move all of this over to the other side of the equation, 4 minus 49, I get negative 45. And then when I move it over to the other side, I get positive 45 over 4. Now if I take the square root of both sides, x minus 7 over 2 is plus or minus the square root of 45 over 4. And I can write that as plus or minus the square root of 45 divided by the square root of 4, which we know the square root of 4 is just 2. So we get plus or minus square root of 45 over 2. So if I rearrange this, I have my x minus 7 over 2. I can now rewrite that as plus or minus square root of 45 over 2. I add my 7 over 2 to both sides. So I get 7 over 2 plus or minus the square root of 45 divided by 2, which I can put over one common denominator of a 2. And if you really wanted to, you could write this as a surd, your square root of 45. That could become, because you've got a 9 times 5 in there, so your square root of 9 gives you your 3 root 5 over 2. And if you were to put this into a calculator, you would end up with two solutions. You would get 6.85, or x could be 0.15. Let's look at another example. We might have that we want to work out when 3x squared take 4x take 9 is equal to 0. Now the first thing that we would want to do here is get rid of this 3, which is attached to that x squared. We want to get rid of that as soon as we can. So if we divide everything through by 3, then here we just get x squared take 4 over 3x take 3, and well, 0 divided by 3 just gives me 0. Now I can start to complete the square on this equation. So I take my b value, I take this negative 4 over 3. I divide it by 2, so I end up with negative 4 over 6, which is just negative 2/3, and I square it. So I've taken that minus 4 over 3, I've divided it by 2, and I square it. And I would end up here with positive 4 over 9. So what I do is I have my x squared minus 4 over 3x, and then I'm going to add on, I should do that bit in purple, I'm going to add on my negative 2 over 3 squared. I've still got my minus 3, and then I'm going to take away my negative 2 over 3 squared. And that needs to be equal to 0. And we work out from the pattern that we saw right at the start that I end up with this part here going into a nice square bracket of x minus, and it's just this bit, this 2 over 3 all squared is how that would factorize. And we saw that with that pattern that we had at the start. And then over here we have our minus 3, and this part subtract, we work this out to be 4 over 9. And that has to be equal to 0. Now we can solve this. So we end up with x take 2/3 squared, and we'll move all of this number stuff over to the other side. 3 plus 4 over 9. So x take 2/3 squared. Now instead of writing a 3, I'm going to write 27. So 27 over 9, okay, plus 4 over 9. Well, that is just 31 over 9. So when I take the square root, I get my x minus 2/3 over this left-hand side, and over my right-hand side, I get the square root of 31 over 9, plus or minus. And well, I can just write this as the square root of 31 divided by the square root of 9, which is just the square root of 31 divided by 3. So my answer is x is 2/3 plus or minus the square root of 31 divided by 3. And putting that over one denominator, a common denominator, 2 plus or minus the square root of 31 divided by 3. And that would be my two solutions for how we could potentially solve this equation here. Now, if you were to put those into a calculator, one of our answers is negative 1.19, or our other solution is 2.52.